This is joint with my colleague Ismail Morifi. So what you can see is this is the U.S. Census, 1990, 2000, and then this is the American Community Survey. Okay, so I'm looking at women 25 to 30, and then the men that are 2 years older than that. Okay. What you can see is that basically the fraction of people who are basically unmatched, they're not either living together and they're not married, is basically, even in this short interval, is basically increasing, okay? Cohabitation is rising, but it's certainly not compensating for basically the decline, the increase in people basically being unmatched. Okay, so the marriage rate is really falling. All right, so I think this kind of statistics is well known, and so I say that. In fact, if you go back to 1970, the marriage rate of these women basically fell by half. Okay, which is an enormous fall, something like 75% to 35% for this age group. Yes.
You know, these people are in a romantic relationship.
Some of them were the cohabitation. So this is all census data. So from 1990, they asked them whether they are actually cohabiting. Before that, there's no even no, they just don't ask. So then I can only look at marriage, okay? So a lot of people, including lots of people in this room, have speculated on why that's the case. So there may be, you can think of it as changes in preferences. Some people argue it's changes in preferences. Some people in this room, changes in household technology, other kinds of technology, culture. There's a lot of recent interest in changes in earnings distribution, okay? That increase in earnings inequality, especially among the less than high school males, basically, they become unmarriageable, and so that may lead to a decline in the marriage rate, okay? So that's a very big, very popular, anyway. And then there are policies. Now, contaminating all these things, there are also big changes in population supplies, especially among the sex ratio in who goes to college, okay? So when you want to evaluate these changes, you have to somehow hold constant changes in population supplies. And let me show you from 1990, you can see that there are more men in that age group having college education than women. By 2010, it's flipped around, right? So you want to evaluate whatever those things that's causal that you think causes changes, drop in the marriage rate, but at the same time, you want to be able to control for changes in population supplies, okay? And already a couple of people in this room, you talk about stigma, you talk about culture. Those are really what we think of as scale effects. They're peer effects. Somebody does something and you want to follow them, right? So then the question is, can we also evaluate these hypotheses controlling for peer effects or scale effects? Okay? Now, what are you going to do if you're an empirical microeconomist? Okay? So let's think about, if I'm an empirical microeconomist, what would I like to do? Okay? Our favorite regression that we run. Oh. Okay. We want to do panel data. Okay? We're going to do diff and diff, right? So we're going to talk about a state and time. That's a marriage market. Okay? There are different kinds of men, so 3 kinds of education level. Different kinds of women, 3 kinds of education level. There are population supplies by basically education level, state, and time. Okay, you can choose to either marry or cohabitate. And then what you really want to do is to predict basically given population supplies of men and women in that state, in that time. And parameters, you're trying to predict basically who's going to marry to whom. Okay? So now, when you try to do that, what do you have to worry about? What you really have to worry about is that everybody who wants to marry a type I man or cohabit with a type I man, okay, plus all the type I men who's going to be unmatched must be equal to the supply of type I men. So these are just accounting identities, right? So whatever model you think you have of who's going to marry whom, you got to make sure you satisfy all your accounting identities. Okay? Now, okay, so this is the regression that we would like to run. Okay? It's a completely sensible thing you want to do, right? You want to estimate who's going to marry whom. Okay? And you want to control for changes in population supplies. And perhaps you want to control for scale effects, right? And you know things are time varying. For example, if you think that, well, there's change in technology, there is change in earning distribution, there is change in reproductive freedom, okay? What are we going to do? Well, we're going to put it in basically in the, so if you ran a Cobb-Douglas earnings regression, not earnings regression, marriage matching function, okay? You want to say the number of type I men married type J women in relationship R in state S at time T depends on some state varying, time varying covariates, whatever your favorite cause is. Then here is you're controlling for supplies. Okay? Now, you can also put coefficients here. Now, the interesting thing here, we know what this means if you do Cobb-Douglas. In Cobb-Douglas, of course, if alpha plus beta is not equals to 1, then there are scale effects. Okay? So it's very easy to think about. If you want to think about peer effects of some sort, what you're really saying is, are there scale effects? And right away from Cobb-Douglas, you can test whether they're going to be scale effects. Okay? So that's the regression that we want to run, right? So here, we understand how to do difference and differences. We understand identification, okay? Easy to estimate. You can, if you really think this is a regression, you just run OLS. You can control for whatever cause you want. You put it in how you think gamma is going to change over time. Control for population supplies, and you can test for scale effects, okay? Now, what's bad about this? Okay, so this is the first thing you like to do as an empirical economist. One problem is not clear where this comes from. There's no micro foundations. Okay? The second issue is that it may not satisfy your accounting identities. What does that mean? What happens is that if you increase something like this as a counterfactual, you may end up getting basically violating one of the accounting identities. You may end up with marriage rates larger than 1. Okay? Because when you run a regression like this, you don't impose that it has to satisfy any accounting identities. Okay, so demographers know this, and basically it's easy basically to violate accounting identities when you do counterfactual experiments. Okay? There's also, the problem here is, if you think about the I as a college-educated man and J as a college-educated woman, okay, this says how many college-educated men is married to college-educated woman in Nevada, say, in 1990. Now, you ask yourself the question, well, what happens if there's an increase in the supply of high school graduates, females? Well, in this model, high school graduate female is another type of female. Well, it doesn't affect how many college-educated men marry college-educated women, right? Substitution effects are basically absent. Right? We know that doesn't make any sense at all. If there are close substitutes and you change the supply of close substitutes, you would imagine that this thing is going to change. But this model says that it doesn't. Okay? So we like some advantages. And what we really want to do is to fix some of this up. Okay? So this is what we propose. So what we propose basically is our marriage matching function, Cobb-Douglas marriage matching function. The only difference we do is instead of putting M of I and F of J, what we replace with is essentially the unmatched males that are type I and the unmatched females of type J. Okay? So let me tell you, for now, let's say you believe this to be true. Well, we know how to estimate this. Yes, that's an endogenous variable, and that's also an endogenous variable. But then you basically just do IV, and you have MI and FJ as instruments. So if you're willing to estimate this equation by least squares, then you can estimate this regression by IV. Okay? So this is really easy to do, right? what's the interpretation? We're going to give a structural interpretation as to this object. This is basically proportional to the gross payoff in relationship R for ij, okay, minus the sum of the gains to them remaining unmatched. Okay? So this is really, you want to think about it, is the payoff to marriage relative to remaining unmatched. Okay? Or the payoff to cohabitation relative to remaining unmatched. That's what this is. Okay? You can test for scale effects. So if you think that there are pure effects or other kinds of stigma effects, then you can basically say, look, test whether alpha plus beta is equals to 1. Okay? It'll satisfy all the accounting identities. Okay? It has spillover effects. Why does it have spillover effects? The reason why it has spillover effects is the following. What happens if I increase the supply of high school females? If I increase the supply of high school females, that will reduce, that will increase the unmatched number of college females. Okay? So automatically, basically increasing the supply of high school females, it's going to increase the supply of unmatched college females. Okay? So right away, spillover effects are going to matter. Okay? It turns out that, so this builds, this particular specification basically builds on a lot of previous work by a lot of people, me, Pierre-Andre, Yoram Weiss, and all kinds of other people. A lot of models are here. What's interesting also is that it also actually can nest another kind of model, which are basically non-transferable utility models. It turns out that that's also in this class. Okay? So I'm going to show you some empirical work, okay, later. But, so this is how we're going to build all these people that we're going to build on. So what are we going to do? First, we're going to use the Logit model as a demand for spouse in a particular relationship, okay? So think about a particular male G of type I who matches with a female of type J in relationship R. That is his utility, okay? This particular person G, who is college graduate, married to another college graduate, can get some payoff that's in that relationship for all IJ people, okay? This is the pure effect, right? He gets utility if a lot of other people like him is making the same choice. Okay? That's what we think of as a pure effect, right? This pure effect, though, could depend on who he is, can depend on the relationship. Okay? Maybe there's no stigma to marriage and there is stigma to cohabitation. So we don't want to say that the pure effects are the same for any kind of relationship and any kind of match.
So this is pure preference, nothing to do with equilibrium, right?
No, pure preference. Right now we're just describing preferences. Okay? This is what he has to transfer to her to convince her to marry him. Okay? And this is the idiosyncratic payoff that he gets from this kind of relationship. And differences in idiosyncratic payoffs means that different college-educated males will choose different decisions depending on what the epsilon actually is, right? So this is just McFadden, okay? Let's see, so done that. Okay. Now, it turns out that we can also say, if you choose to be unmatched, you know, it depends on how many other drinking buddies you have, right? So there's no reason to assume that there is no pure effect if you actually decide to remain unmatched. Okay? If you don't have a lot of drinking buddies, that may not be so cool. Okay? So basically, by the way, we built on Brock-Deloff, who has these pure effect models. All right? So then, what does this guy do? Well, he decides whether he wants to be unmatched. He wants to be married to a college-educated woman. He wants to cohabitate with a college-educated woman and all the other choices he could make. Okay? And this is McFadden's famous result, right? McFadden's famous result says that if these are preferences and the epsilons are type 1 extreme value, then the log odds of him choosing relationship R relative to remaining unmatched is basically equals to the mean utility from that behavior plus the payoff, this is the peer effect payoff, minus what he has to pay, minus the payoff from remaining unmatched, and the peer payoff from remaining unmatched. Okay? So that's a quasi-demand of type I min for relationship R with people J, with women J. Okay? Women, we do exactly the same way. Okay? So basically, she's thinking about marrying him. She gets some mean payoff. She may have some peer effects as well. It's an interesting question you could ask. Well, are men and women more affected by what their peers think, and how many of them are trying to do the same thing? Okay? Here we don't impose. This should be a J. Okay? So and she gets the transfer. Okay? And all these epsilons are also type 1 extreme value. Right? You do that, you're going to get the quasi-supply equation of type J women for type I men for relationship S. For relationship R, sorry. Okay? Now, what are we going to do? Well, what we're going to do is we have a demand equation. We have a supply equation. Okay? And we're going to use the transfer to clear the marriage market. Okay? So that's what this says. We basically equate demand equals supply. And then you're going to end up with our marriage matching function. Okay? Miraculously, the transfers cancel out. And what you can see is the number of IJ matches in relationship R, okay, depends on the number of unmatched men, the number of unmatched women, okay, and the gross payoff to marriage relative to remaining unmatched. Okay? So this is basically a special case of the Cobb-Douglas that we wrote down, except that, of course, now there are restrictions on parameters. Okay? So let me tell you, what happens if all the peer effects are exactly the same? Okay? All the peer coefficients are exactly the same everywhere. They're not zero, they're positive, but they're all exactly the same. This is Mansky. Okay? And what happens if you do Mansky, you basically cannot differentiate between Mansky and the original CEAR model in which there were no peer effects. Right? So Mansky basically say, listen, it's not identified, and that's exactly right. We get back Mansky's result. If all the peer coefficients are exactly the same for every possible choice, you just exactly get back CEAR. So you say, I can't reject CEAR. Well, you can't reject a model with peer effects either. Okay? That's the first result. But on the other hand, it's different. I mean, it's not as negative as Mansky. Why is that? It's not as negative as Mansky because it says that in general, if you don't have homogeneous peer effects, then they are different. Okay? So there's a lot of room because it's something you can actually test. Right? So that's basically what it says. It's that basically if the peer effects are not all the same, in fact, in general, it won't be equals to 1/2, 1/2. Okay? Yes.
Question. So what's the market here? The market is a state in a particular state in a particular year.
State in a particular year, yes.
But you're imposing that those phi and so on, all your structural parameters are invariant across states and across time. I mean, at the end of the day,
yes,
the CEAR model is exactly identified, so a model in which, in addition, you have peer effect is not identified unless you assume that some coefficients are.
Of course. So that's exactly right. It's exactly what we do in difference in differences. Whatever you can relax in difference in differences and exploit the cross-state, cross-time variation, you have to hold something constant, right? Yeah. And you can hold as much as you can. Whatever you can hold constant in diff and diff, you can hold constant. If you relax it enough, you lose identification. Absolutely.
So no, but my question is, what is it that you assume constant?
For now, when we do empirical work, we basically assume that these things only depend on R. I think we actually try IJ also. We allow it for R and we allow it for I and J. But we don't allow for S and T. So if you relax everything, we lose identification.
So the merge market has the same determinant in a sense. It just happened that in different states, at different moment, the populations are different, but preferences, the distribution of preferences are the same and so on.
Absolutely. But I think that's really the choice of the researcher.
Yeah.
Okay, I mean, so that's what we choose, but you could pick another choice, right? That's the point. I want to stay near basically difference in differences. Okay, and whatever you think, how you want to do things, I'm going to give you enough flexibility for you to worry about what your favorite causal mechanism is, and to let you control for some pure effects and changes in population supplies. That's the way I think you should think about it. I think from a theory point of view, there is a little, I was always uncomfortable because the CEAR model is about transferable utility, and then we see other people use non-transferable utility. And I was always very uncomfortable in the sense that, I'm thinking to myself, how can this be? I mean, these are two corner models, and how can I tell which one is correct? And I can't seem to tell, okay? What's kind of interesting here is that it turns out that if, in fact, these coefficients, the Cobb-Douglas coefficients, is equals to 1, okay, which it can be, you get back the Daswick-Manzel marriage matching function. Daswick-Manzel, for those of you who know Daswick-Manzel, and those of you who don't, is basically a non-transferable utility model of the marriage market. Okay? They use a stability argument to get an equilibrium, the no transfers, but if these things are equals to 1, we get them as a special case, right? What does that mean? What that really means, the way to think about Daswick-Manzel, okay, is that basically they have a marriage matching model with scale effects, right? How can we replicate it? It's basically if you assume pure effects of unmatched is 0, and basically when you match, you get positive pure effects. That's one way to get scale effects. Okay? Now, I interpret that as a pure effect. Daswick-Manzel wouldn't interpret it as pure effects. They would just call it scale effects. Okay? So there's no particular reason. That's why I went down to Cobb-Douglas, right? You don't necessarily have to take a stand and say, this is a transferable utility model with pure effects. Right? This is basically, the way I want to think about this is that that's a model you can estimate, whether you want to interpret it as a transferable utility model with pure effects, or whether you want to think about non-transferable utility. We don't really take a stand. In fact, this class of models, using this data, you can't really tell. Okay, so there's no reason to take a strong stand how the market clears, basically. There's just not enough evidence looking at data of who marries whom and who remains unmatched. Okay? Okay, some other restrictions you put on is a very nice result, basically by Pierre-André Solagny and Weiss. Essentially, you get the Cobb-Douglas with constant returns to scale. Okay, so that's just basically their first. They were basically the first to generalize in a non-trivial way the CEAR model, which was very nice, and then so we're just building on this stuff. Now, one thing which is kind of interesting, which is if you look at Pierre-André Solagny and Weiss, you look at CEAR, you look at Daswick-Manzel, one bad property of those models, we don't point that out, but I'll point it out to you now, is that if you look at the ratio of cohabitants to marrieds of IJ, it will be independent of population supplies. If you change population supplies, the ratio of cohabitants to marriage will not change. Okay?
That's an IIA kind of thing.
That's an IIA kind of thing. Well, no, that's it. Well, that's also in Daswick-Manzel. So I'm not sure what exactly it is. Okay? It turns out once you put in pure effects, that's no longer true. Okay? You begin to deviate. And so in general, the Cobb-Douglas case allows you to deviate Now let me tell you why this is not a good thing. Peter Acediacono and I think Marjorie McElroy and some other people basically try to look at high school relationships with and without sex. Okay, and they show you that the relationship of high school relationships, the ratio of sexual to non-sexual relationships, depends on the sex ratio in that school. Okay, and asking my non-random sample of junior colleagues, they also don't believe that the ratio of cohabitation to marriages are independent of the sex ratio. Okay, it turns out that in like those earlier models, you just get it. Okay, but here's at least a way to relax it. All right. Now the question is there any bite to the pure effects model? It turns out that there is. Okay, you can work through some algebra, not that interesting. In fact, you can test whether the pure effect model is true or not. You estimate the Cobb-Douglas model, and it's a restriction on some coefficients on the Cobb-Douglas model. Okay. So you estimate the Cobb-Douglas model, and here are all the different, this is the pure effects model. So they say some ratio coefficients have to be the same. All right, so how much time do I got?
Oh, like 20 minutes.
Oh, okay, so I should be able to do this. So I'm gonna do two little exercises. One exercise, the first exercise is simply to test some of those special cases. Okay? So basically, we have, I told you, 26 to 30-year-old women and 28 to 30-year-old men, okay, in the states. That's fine. Each state is considered an isolated marriage market. Individuals are distinguished by their schooling levels. We only picked 3 schooling levels. The reason for that is that once you go to the state level and time, the cells get very thin. So it's really a trade-off between finer schooling grids, and then I'm going to run into thin cell problems. Okay? The reason I'm starting in 1990 is that in 1990 was the first time they asked a question in the census where basically whether a respondent answered that they are the unmarried partner of the head of the household. That's how we define somebody, a couple as cohabiting. All right?
Sorry, the age window, because basically nowadays the median age of first marriage in the US is 27, but in 1990, I mean, probably it was 12,
Absolutely.
24. So don't you move the age
we could do that. So I could do that. Or basically another way to say it is that the gains to marriage is not going to be stable if I hold the age window constant. So I need some time varying coefficients.
Because,
Yeah.
especially from 90.
Absolutely, absolutely. So there are lots of reasons why you want time varying coefficients. Okay? Absolutely. You can see I do run into some thin cell problems. You can see that for the men, I have 1,300 observations for males and females and unmatched. But then when you go into cohabitations and marriages, some states, they're just too little in some particular educational group. Okay, so I run the thin cell problems. So the first thing I do is I estimate this by ordinary least squares. Okay. Now, if I did this by ordinary least squares, you can see if I don't put in anything other than the log of the unmatched, okay? Wow, true CEAR looks really good, almost 1/2. Okay? Unfortunately, for cohabitation and marriage, by the way, unfortunately, as you put in more covariates, they really move away. So for sure, you reject the true CEAR model, okay? So what did I do here? I put in year effects, state effects. Okay? So when you put in year effects and state effects, you can see that you're going to reject true CEAR. Okay? Now you can still argue, well, are there constant returns to scale? That's not too bad, adding to 1. Okay? What do I have here? I seem to be adding more stuff. Oh, yeah. So here I put in state effects. Once you put in state effects, it turns out that you're going to reject that the sum of these things are equal to 1. You're going to find scale effects. So if you don't put in state effects, perhaps you won't even reject constant returns to scale. Okay? Now, this, though, of course, we shouldn't be doing ordinary least squares. Okay? Now, one thing just for you to realize, by the way, is that where is my R square? By the way, this is panel data. You can see, by the way, you're already explaining a lot of the variance, okay? Now, why am I explaining so much? Basically, I'm explaining a lot, basically, with match-specific effects, right? All this has match-specific effects, okay? If I don't put in match-specific effects, you can see that my R square is only about 0.5. But once I throw in match-specific effects, okay? So I'm not really explaining anything. I'm just telling you that IJ people like to cohabitate or they don't like to cohabitate with each other, okay? So there's a lot of room for you to think about, okay, what is in these fixed effects or match effects that this guy is putting in, right? Basically, without match effects, I'm only getting something like 0.51. So there are a lot of action going on in match effects, I don't know what it is. Okay? What am I doing here? Oh, so I'm estimating this with instrumental variables.
I guess the more interesting thing is what's in the time dummies.
Absolutely, what is in the time dummies? Okay, so this is really just, as I've said, this is just a description of the data, right? It's a disciplined description of the data, and you have to think for yourself, what is in the time dummies? Okay, is it state varying? Okay, you read the paper, we do some minor experiments, okay? Let me just say, taking whatever it is, we don't reject the peer effects model. Whether you want to take it seriously or not, it's up to you, okay? But at least we don't reject the peer effects model. The coefficients are not that different when you do IV versus OLS, okay? So this is the way to test things, but we don't know what it is. So I'm going to evaluate a particular hypothesis that somehow people seem to be interested in right now, okay? Which is, I first came onto this, basically, I was discussing, somebody asked me to discuss Jeremy's paper at the AA meetings. And so I was discussing, and the issue was, did earnings inequality affect marriage behavior? So we know earnings inequality has gone up. So the question we want to ask is, how much can it explain the fall in the marriage rate? Okay? So this seems like a reasonable thing to do, given this kind of a setup. Right? So what am I going to do? Here, you can see now data. Right? You can look at, this is the young men between 1970 and 2012, distribution of log earnings. And you can see that this is 1970, and this is 2012. This is what we call increase in earnings inequality. Okay? Wages, I think those are just earnings. You should just think of them as earnings. Okay? So what that tells you in our data set, basically, that's an increase in earnings inequality. Okay? The question is, how did this affect the marriage market? So this is happening for men. This is happening for women in different educational class. What did it do to the marriage market? Okay? Okay, now here's an interesting first pass, right? We look at the male, oh, by the way, this is joint with, let me just say the following. This is joint with Kirsten, who's a graduate student. So she's going to be on the market. If you're looking, she's very good. What am I doing here? On the horizontal axis is basically the male wage ratio of college to less than high school, right? So if we move in this direction, this is an observation is basically a state, right? The way to think about this is that this is increase in earnings inequality. Some states, there's more earnings inequality than other states, okay? In 1970. What about the marriage rate for females? The marriage rate for females, you can see that at least in 1970, there seems to be more earnings inequality among men. The marriage rate for female is falling. Now, the relationship is not that stable because if you did the same thing for 2012, that doesn't quite work. Okay? Now, one thing is interesting, by the way, you can see where the mean of the sample is here. The mean of the sample earnings inequality is here, right? About less than 2. And you can see, by the way, earnings inequality has gone up. It's now larger than 2. Okay? Even if you look at the best case, if you project this up to over 2, you're not going to get the marriage rate in 2012. This is the actual observed marriage rate. Right? So it tells you, yeah, we can project this out. We can move earnings inequality over. But you ain't going to get there. Okay? So this is without any model. Right? So those guys who say qualitatively, could it work? It could work qualitatively. But quantitatively, the magnitudes are all wrong. Okay? This picture is going to tell you it's all wrong. All right? So what do? So we go back to CEAR-HCEO. We got lazy. Actually, it's not that. This was really for something else, and we were restricted in what we could do, so we're extending it to a paper. But anyway, we went back to CEAR-HCEO, so we shut down all the peer effects, etc. And this is basically the gamma ij, ST. Right? What do I do here? I look at male earnings by educational group, female earnings by educational group, and interaction between male and female earnings. Okay? That's the only thing that I'm doing, which is basically the gamma ij. So other than match effects, now I'm going to allow it to be time and state varying. And the time and state varying is basically by differences in wages. Male wages, female wages, and then male interacted with female wages. Okay? These are in logs. What's, to me, kind of interesting is that the coefficient on the interaction term is negative. Okay? What does that mean? This is exactly Becker's hypothesis. Okay? That marital output, that basically spousal wages are substitutes. Okay? Now, how did I manage to get this? The reason I managed to get this, okay, is that I'm holding the IJ match constant. In other words, I'm holding that a college male is married to a college female, and I'm going across state and time to look at the variation of earnings. And then I can tell you that, in fact, if earnings go up, they are spousal substitutes. Right? When Becker says, look, I can't explain why college-educated men and college-educated women marry each other because they're supposed to be substitute, the point is it's hard to separate preferences from spousal earnings. Right? And then we say, well, Becker's wrong. The point here is, here is a way to try to think about at least a version of a test of Becker. Okay? Where we basically hold the match constant, and we look at the wage interaction effects. Yes?
In Becker's framework, if the woman's wage is low, she would most likely not participate in the labor market. So here you have wages for the women.
Absolutely. So I don't want to say, we don't have the extreme specialization that Becker has. A lot of women are now working. The question really is the following. I like my wife to be rich, but if I'm rich, maybe I don't value it as much. Right? That's really the force of Becker. Right? Is that I like her to be rich, but if I'm rich, I don't value it as much. And this is exactly what this says. Okay? Yes?
I mean, two things. One is that you can't distinguish between matching and labor supply here, right?
Absolutely.
So he could still be trying to get a very high quality wife, but then she stops working because her time is
absolutely. So we haven't explored. We could do probably a bit more about what a wage actually. This is right now is just the mean wage of college graduates, male college graduates, the mean wage of female college. You're absolutely right. It mixes labor supply.
And two, I'm pretty sure if you control for female age, that flips. That's
a good question. Okay, so let me just say the following. as I've said, we only have like 3 groups with women in one age group. Okay? We certainly want to basically have more types of men and women. We want to go beyond CEAR. Okay? So think of this as I don't know, just a beginning. Okay? Right. So this is the data. This is the actual data, right? You can see this is the marriage rate of women in this group. They're over 70% in 1970. And in 2000, they're something like 35%. Okay? And you can see, by the way, the marriage rate, it used to be that the marriage rate of college-educated women were the lowest in 1970, and then in 2010, they're slightly higher than the other groups. Okay? The first thing we tried to do is, well, what happens if we control for population supplies, changes in population supplies? And you can see that if you try to do true CEAR, you simulate the model, and you just look at changes in population supplies, it goes the wrong way. Okay? Well, you could argue that it goes the right way a little bit for college-educated women, but certainly for the other 2 groups, it's moving the wrong way. Well, what happens if we look at changes in population supplies and changes in wages? Right? This is the argument. Did increase in earnings inequality, can it explain the fall in the marriage rate? And you can see that it doesn't do it. Well, it certainly makes it drop a little bit. So the direction actually doesn't even work for high school graduates. Okay? And it doesn't really work for college graduates either. So what this tells you is that it's kind of interesting to think about the change in college, the change in the earnings distribution. But it tells you that most of it is basically a residual, that we don't know what it is, at least here, right? But a lot of you in this room have basically explored other hypotheses, right? And it just tells you that, look, there's a big gap. So let me stop here.
Question?
Yes?
These inequality effects.
Sorry?
The inequality effects are very natural to apply to a search model.
I'm sorry.
So if you would have used the search model of matching, you would get this result with the more variance there is in properties of male. Women would search longer. It's a standard result in search model.
Oh, right, right. So, right.
So one of the issues is really whether we believe in search models or models without friction in terms of the modeling.
That's a good question. That's a good point. I have to think a little bit more about that. Okay? I think that's a reasonable point. Now I wonder, you say this is basically imposing true CEAR, so we're shutting down pure effects. The issue, what would be kind of interesting if you want to think about the search context, is to estimate the model and see whether you can find any scale effects, and whether the scale effects are going to be important. Okay? Maybe the scale effects would change these results quite a bit. I don't want to say that because I shut it down, so I can't tell you what would happen if we estimated this model with scale effects. Okay? Doesn't quite get to where you are, but at least there's a way to try to think about some of the issues that you raise. So it's a good point.
Thank you.
Thank you.